Now we're going to look at something called separable differential equations. And if you notice, I've given you two equations, dy dx equals 6x, and dy over dx equals 4xy. Right off the bat, we notice that the green equation has an extra variable in it. It has a y in it when we're trying to find the antiderivative. So it is possible for us to find the antiderivative of these equations. We're just going to have to separate the variables. We're going to need all the y's on one side and all the x's on the other side so that we can find the solution to this differential equation, so that we can find the antiderivative. So if I was going to find the general solution, for example, find the general solution for dy dx equals 4xy. I can do that. The first thing I'm going to have to do, though, is separate the variables. So I'm going to take my equation, which is dy dx equals 4xy, and the first thing I'm going to do is separate x and y. So in order to get rid of the dx, I'm going to multiply by dx so I can move it to the other side, which is going to give me dy equals 4xy dx, and then I notice my right side of the equation still has a y in it, so I'm also going to divide by y on both sides, which will cancel this y and leaves me with dy over y equals 4x dx. Now all my y's are on the left side, all my x's are on the right side, and I can actually start to solve this differential equation. And from here, I'm going to do the same thing I did last time. I'm going to take the antiderivative of both sides, and then I'm going to simplify as much as I can. So my next step would be take the antiderivative, and remember our symbol for antiderivative is that big squiggly S. Take the antiderivative of both sides, and I want to make sure I'm showing anyone who is looking at my work what I'm doing. So I go in and I actually put the antiderivative symbol into my equation, and then I look at it and I say, oh, gross, dy over y. I'm not a fan of fractions, so let me rewrite that, at least so I can separate the dy and the y. So I pull my fraction apart. I'm going to keep the other side for now, so now that I can take the antiderivative of both sides at the same time so that I don't accidentally skip a step. So then I notice the antiderivative of 1 over y, I know is the natural log of the absolute value of y equals, and now I'm going to also take the antiderivative of 4x, which is going to become 4x squared over 2 plus c. Now, if you notice, I only put the plus c on one side of the equation. We only need to add a constant to one side. Only 1 plus c necessary. Because if I had added a constant to both sides, for example, if I had made it natural log of y plus some constant equals 4x squared over 2 plus some other constant, when I start to simplify this and solve for y, when I subtract this constant from this constant, I still have a constant 4x squared over 2. I have some other constant on the right-hand side. So rather than making extra work for myself and having to move constants around, because when I take a constant or I take any number and I subtract another number, I'm still going to get a number. I just kind of bypass that step when I'm solving just to simplify it a little bit for myself. So I only need one c, and I intentionally put the c on the right side of the equation because I'm always going to be solving and trying to get the left side all by itself. So it just makes it easier for myself to do that. The last step I'm going to take, step 3, will be solve for y, because that'll give me my general solution. So I go back up to my equation and I look at it and I say, okay, how do I get rid of an ln? And I know I get rid of an ln by raising both sides to the e. So now that I've canceled out that ln, I can also get rid of the absolute value symbols because it doesn't matter anymore. My y is going to be positive because it was already applied to the ln, so I know I can't put a negative number into my natural log. So I can, when I get rid of my ln, I can also get rid of my absolute value signs. On the right side, I'm going to have e to the, I'm also going to simplify this 4x squared over 2 to just be 2x squared plus c. Now I can leave it like that and that can be my final solution. Or if I want it to be extra fancy, I know that when I have two exponents that are adding together, that means they originally had the same base and were multiplying. So I can break two exponents apart that are adding by bringing the base to both of them and multiplying those two numbers. Then I also know, because this is me being super fancy, that e to the c is e to some number, and a number to a number is just going to give me another number. So I really just have one big constant times e to the 2x squared. And that would be my general